Hi, this is Rakesh Chaudhary. Now I am explaining about eighth experiment in operating systems lab. Operating systems lab. The title of this experiment is implementation of deadlock avoidance algorithm. It is also known as Banger's algorithm. The aim of this experiment is to write a program to simulate Banger's algorithm for the purpose of deadlock avoidance using C++ or Python. The description of this experiment is in uh, a multi-programming environment. Several processes may complete for a finite number of resources. The process requires resources. If the resources are not available at that time, the process enters a waiting state. Sometimes a waiting process is never again able to change state because the resources it has requested are held by the other waiting techniques for handling deadlocks. This approach requires that the operating system be given in advance additional information concerning which resource a process will request and use during the lifetime. With this additional knowledge, it can decide for request whether or not the process should wait. To decide to decide whether the current request can be satisfied or must be delayed, the system must consider the resource currently available. Current the resource the resources currently allocated to the each process and the future requests and releases of each process. uh, Banker's algorithm is a deadlock avoidance algorithm that is applicable to a system with multiple instances of each resource type. Algorithm of this experiment: uh, start the program, get the values of resources and process, get the avail value. After allocation, find the need value, check whether it's possible to allocate. If it's possible, then the system is in safe state. Else, system is in not safe state. If the new request comes, then check the state, then check the system safely or not. If we allow the request, stop the program. Uh, the uh, the program of this experiment is int iostream using namespace standard int main int n comma m comma allocation 10 into 10 max 10 into 10 avail 10 k comma pid comma request of 10 cout enter the number of process cin n enter the number of resources cin m for int I equals to 0 I less than n I plus plus cout enter the details for process I endl cout enter the allocation values for process I endl sin allocation allocation of I of 0 allocation uh, allocation of I of 1 is greater than allocation of I of 2. Cout enter the max values for process I endl cin max I of 0 max I of 1 is greater than max I of 2. Cout enter available resources endl for now using for loop int I equals to 0 I less than m I plus plus C in uh, avail of I, int need n of need of n of m, int f of n, comma ns of n, ind equals to 0. For k equals to 0, k is less than n, k plus plus. F of k equals to 0. For int I equals to 0, I less than n, I plus plus. Need of I of j equals to max of I of j minus allocation of I of j into y equals to 0. For k equals to 0, k less than n, k plus plus. For int I equals to 0, I less than n, I plus plus. If I equals to 0, int flag equals to 0. For int j equals to 0, j less than m, j plus plus. If need of I of j is greater than avail of j, flag 1 equals to 1. Break. If flag equals to 0, ans of ind plus plus equals to 0, plus plus equals to I. For y equals to 0, for uh, y is less than m, y plus plus avail of y plus equals to allocation of I of y. Cout bar n bar n bar t bar table for bankers algorithm bar n. Cout available resources, avail of 0, avail of 1, avail of 2. Cout process allocation, max need. For int I equals to 0, I less than n, plus plus I. Cout p I plus 1. Cout allocation of I of 0 is less than allocation of I of 1. For same max for need. Cout bar n. Cout following is the safe sequence. For int I equals to 0, I less than n minus 1, I plus plus. Cout p less than answer of I less than minus greater than. Cout in the brackets p ans of n minus 1 endl return 0. Now I will debug and run the program. For input, enter number of process. I will give 5. Enter the number of resources 3. Enter the details for process 0. Enter the allocation values for process 0. Enter 1 0. Enter the max values for process 1. Enter the details for process 1. Enter the allocation values for process 1. Before 4, enter the max values for process 1. Use for enter the variable. This is the available resources 47, 24, 30. For process P1 allocation max need. For process P1 allocation is 105, max 322, need 2 comma 2 comma 3 minus 3. Like this is the available resources for P1, P2, P3, P4, P5. Check once. 2, 4, 32, 12, 234, 321, 10, 230, 456, 234. Like this. For following is the safe sequence. P0 is greater than P4 is greater than P32 is greater than P0 is greater than P0. This is the